Okay, in this section, let's get this up. We want to discuss combining radicals. Alright, so really all we're talking about is addition and subtraction. Okay, just talking about addition and subtraction, and kind of think of this like fractions. You know, 1/2 plus 2/3. We cannot add fractions unless we have a common denominator. So in this case you'd have 6, that'd be 3/6, and this would be 4/6. Then you can add them. Now that they have a common denominator, and the reason why you need a common denominator because the answer has to have the same denominator, and you just add the numerators. 3 and 4 will give you 7. Alright, now you have to have common denominators to add fractions. Well, with radicals you have to have a common radical, and not just talking square root, but the number under the radical has to be the exact same. Okay, so let's look. Okay, say we have 3 square root of 8 plus 2 square root of 18 minus 4 square root of 2. Now, if you have a listing of terms that you're trying to add and subtract, and it deals with radicals, understand that you cannot combine them unless the radicals are the same. So I cannot add this 3 square root of 8 to anything or subtract it from anything unless the other term has square root of 8 in it. This does not have square root of 8 in it, so I can't, as it stands right now, add it with this. This does not have a square root of 8 in it, so I cannot, as it is right now, subtract it with this. Okay, same here. 2 square root of 18, I would need this to be an 18, square root of 18. I need this to be a square root of 18 to do this. This 2, I need this to be a square root of 2. I need this to be a square root of 2 to combine it with this. Alright, just like with fractions, you have to have a common denominator. Here you have to have the exact same number under the exact same kind of radical. So all of them square roots, and they all have to be the same number under the square root. Now we don't care about the numbers outside the square roots or outside of the radical. Alright, now when you're looking to deal with a problem like this, I would suggest that you find whatever the lowest number is under the radicals. In this case is 2, and see if 2 could be simplified any further. And in this case we know that 2 can't. There is no factor for 2 that is a perfect square, okay, other than 1. Alright, so 2 cannot be broken down any further. So what that tells me is these other 2 terms likely need to be broken down to a 2 in order to combine it with this. Okay, so what I do is I say, alright, well I know I got to break down the square root of 8 and this 18, and I need them to be square root of 2's so I can combine with this. So 8 divided by 2 leaves me a 4, and guess what? 4 is a perfect square. 18 divided by 2 leaves me a 9, and guess what? 9 is a perfect square. So if you look at it, now you have 4 times 2 is 8, 9 times 2 is 18. Okay, and you know that 4 can be broken down and 9 can be broken down. So now you have your 3, alright, times your square root of 4 times your square root of 2. Alright, that's this first one, plus your 2 times your square root of 9 times your square root of 2, because 18 is 9 and 2. Alright, and this last one is 4 square root of 2, because the 2 cannot be broken down any further. Alright, and we know that the square root of 4 happens to be a 2, and then we can't break the 2 down, plus keep our 2. We know that 9 square root of 9 is a 3, and we can't break down the radical 2 any further, so it stays there. And again, this one we said we can't do anything with, so we leave it alone. Now 3 times 2 is 6 square root of 2. 2 times 3, 6 square root of 2 minus 4 square root of 2. So now they all have square root of 2 in common. So now I can combine them. So I can say 6 plus 6 minus 4. 6 plus 6 is 12, minus 4 is 8. And my common radical is square root of 2. So 8 square root of 2 would be the answer. Okay? Alright, let's look at one for cube. So let's say we had a perfect cube situation where we have 5 cube root of 2 minus 2 cube root 16 minus 6 cube root 54. Okay, so I have these, and again they're all under the cube root, but the number under the cube root, they're all different numbers. So those numbers need to be the same in order for me to be able to do anything with it. Excuse me. Okay. So what I need to do is find the lowest number under the cube root. In this case, is a 2. And once again, I know 2 cannot be broken down any further by a perfect cube other than 1, and 1 doesn't change anything. If I divide 2 by 1, it's still 2. So I've not helped myself in any way. Alright, so I leave the 2 as is. So I keep my 5 cube root of 2, leave it alone. Now I see I have a cube root of 2 here, so in order to be able to combine these with it, these need to break down to a cube root of 2. So (16) divided by 2 is 8, and 8 is a perfect cube. Again, I know this one needs to break down to a cube root of 2 and something. Oops, excuse me. Didn't mean to write that 2 there. I wrote it over there. Okay, so now I say 54 divided by 2 is 27, and 27 is a cube root. Is a perfect cube. So now I'm in good shape, because now I have a perfect cube here, perfect cube there, and I have my cube root of 2's in common now. Okay, so here I'll just bring this down. 5 cube root of 2 minus, I have my 2 right here. Now the cube root of 8, okay, or here I'll write it out, and the cube root of 2 minus the cube root, oops, forgot my 6. Forgot my 6 right here, so I keep my 6 there, and then I'll write my cube root of 27 and my cube root of 2. Alright, because 2 times 27 is 54, 2 times 8 is 16, 2 stays the same. Alright, so 5 cube root of 2 minus 2 cube root of 8 is 2, and you're left with cube root of 2 minus 6 times cube root of 27 is 3, and you're left with cube root of 2. Bring my 5 down. That's now a 4, and this is a 18. So 5 cube root of 2, 2 times 2 is 4 cube root of 2, 6 times 3 is 18 cube root of 2. So now I say 5 minus 4, which is positive 1, 1 minus 18, which is a negative 17. Alright, and the common cube root is 2. So there's your answer. Okay. Alright, so that's pretty much all there is to it, to combining radicals, whether it be square roots or cube roots. Again, you're just trying to break them down to the lowest number under the radical sign, if at all possible, and then you combine them once you get that the radicals and the number under the radical to be the same number. Alright, we will now conclude this session.